Okay, let's talk thermodynamics versus kinetics. First question, will a reaction even happen? A piece of granite could sit in a puddle of water for 10,000 years and not react. So now let's say you do have a reaction. Thermodynamics tells a scientist how much of a product will there be when the reaction has finished its course. Let's say your chemical reaction is a campfire. If you let your campfire reach equilibrium by letting it burn all night, then there will be a whole lot of soot and barely any wood left to come back to in the morning. Kinetics tells a scientist, okay, so a reaction has happened. How fast did it happen? Does the reaction take place in 10 milliseconds, or does the reaction take place in 10,000 years? Remember that granite rock? Maybe it's just actually reacting with the water, but it just takes way too long to measure any noticeable change. I kind of like to think of kinetics like poking someone with a stick. How long will it take to make this person react? A little kid will probably react really quick and say, hey, stop that. But maybe if I'm poking a Buddhist monk, then there will never be a reaction due to how patient he is. In chemical engineering, the engineers like to use thermodynamics to manipulate a reaction to see how much product they can form. And they like to manipulate kinetics to see how fast they can get a product to form. Think of a lemonade stand, because if you're a kid selling lemonade, you better believe that if you're selling a whole lot of lemonade, that you're going to be trying to make as much lemonade as you possibly can from as little powder as you can, maybe by diluting it with a bunch of water, aka increasing the thermodynamics. Or maybe you're going to try to make your lemonade as fast as you can in order to sell as much lemonade as possible, aka increasing your kinetics. So that was a brief intro to thermodynamics versus kinetics.